New Delhi and New York, even like Cape Town, in different parts of the country. These things, especially in Europe, there is a lot of these admiration and conservation around traditional past and historic monuments. The only way that we can make the traditional systems work is if we engineer it and make it adapt to the modern building. Because today's the typology of buildings in today's date is extremely different from the way traditionally buildings used to be designed. So I'll be talking very briefly about the work that we do on these lines of nature-based design and climate responsive architecture. Like most of it that I'll be talking is something that's very basic common sense, and I'm sure most of you are aware of it. So especially I think in Indian context, all the systems that we explore are something that either as a student or as a kid, something I've seen, grown up and explored while like growing up, seeing the solutions. I'm sure, and probably even while traveling, we see that, okay, this is how traditional systems used to work in the past. And the idea of the practice has been that, like, I mean, ever since I was a college student, I always used to think, if there is so much that's already there, and especially in India, when we talk about this, the beautiful, like the picture perfect image of India, I would rather call it as the postcard picture perfect image of India. So what I mean by that is that when you talk about postcards, and they always talk about the best part of the country, right? I think that's what you really show. And when you talk about it, this is what you really showcase to the world, saying that this is what is India. And so when I was studying in Europe, I was doing my my master's in robotic fabrication, advanced technologies. How can we bring robotics into the construction industry and so on? One thing that really amazed me is that while we were studying these things, especially in Europe, there is a lot of these admiration and conservation around traditional the past and the historic monuments. And that's one of the motivation for me to actually come back to India rather than pursuing working abroad, is that when we have so much in here, why can't we take those things and then try to improvise on those and take it forward? So like the idea has been that, like, especially when we talk about climate, culture and craft, like which I was talking about. So in India, when you travel in different parts of the country, there is always this inherently beautiful elements that are available in all the states, right? I think that's what we see and observe. And every state has a different texture, the fabric, and different way that like the architecture has evolved in the past. And but today, it is very difficult to like really distinguish which city is which. Can you make out like which are the three cities in here? Any guesses? Anyone? No? What about this? Yeah, sorry? Varanasi, Jaipur, Madurai. So, and that is the the most striking thing is that in today's date, it's very difficult to understand, and we lost that identity to the context. And whenever we design buildings, it's not just India. I think we can, the concept of globalization, when you talk about it, it's very difficult to make out the buildings between New Delhi and New York, and even like Cape Town. In different parts of the country, we start seeing this texture to be like completely dissolved to the state that it's very difficult to make out. I think we are losing this strong identity that should be connected to the place. But so if we step back a little bit and understand the basics of traditional architecture, it's very simple. It's actually what we see in here. You'll realize that it's super. Sorry, I just forgot to turn it off. Yeah. So the concept of traditional architecture is like it revolves around the response to the local climate, and the buildings are designed to last ages and generations. Now today's date, the modern buildings are designed to last how many years? Can anyone guess? 10, 15 years. And very soon, even if they're structurally sound and intact, they lose their identity and trend, whatever, like pretty quick. And another very important aspect of traditional way of approaching buildings is the response and the use of local materials in the way that they used to be designed, right? And everything used to be local. So if there is any problem, or if you have to even replace, you can always source a replacement like from a very close proximity, and the buildings used to still thrive and extend the life of it. And the spatial planning was always used to be according to the context. And there's always this touch and connect with the nature, right? The surroundings and the landscape, all the buildings that we admire, most of the buildings, I'm sure Ahmedabad, by the way, is a great place. Some really amazing work that happens, and we always look for up to this city, one of the good cities in the country. So So there's always this nice touch to the exterior and the connect that always there. And the indoor, and there is this also this the discussion around the indoor climate, how the spaces are designed, and it's connect with the outdoor, and so on. So inherently, traditional architecture always meant climate responsive, and that's how the architecture we see, whether it is in Kerala or Rajasthan or Ladakh, and all of these things have evolved. The typologies have evolved based on how it responds to the local climate. Can anyone, like, I'm sure the states are already there. So what is the difference in these three buildings? Can anyone attempt to just talk about it? What's the difference between all these three typologies in here? Sorry? Climate. Yeah, that's, I'm sure. But in the first case, in Ladakh and the difference in Rajasthan, so what is the difference between the buildings that are done in here and there?
What they used in Rajasthan is like the material used in the Rajasthan building is quite cool in nature. So in hot weather it keeps the building cool.
In hot weather, it keeps the building cool. Okay, and what about in Ladakh? Stone walls. And stone was used extensively in Rajasthan as well.
There is also wood keeps the interior material.
Local materials. Okay, definitely yes. And in Kerala? Sloping roof. Rainfalls. Courtyards. Yeah, and one, I mean, I'm sure the basic parameter is that in Ladakh, you want the windows to be like really big to gain the heat and hold it. The thermal mass, you create the thermal mass so that the heat is not dissipated. You're collecting it during the day and releasing it in the night. And whereas in Rajasthan, if you look at these textures, those windows are still like bigger, but then these are all perforated jalis. So you're not actually, you want light, and at the same time as the air is entering, we want it to be dissipated. It's not, you don't want the air to be coming as a gush. So there is this pressure difference. If you look at the cross section of this jalis, it's beautifully crafted that way. And when you talk about any humid climate, not just Kerala, you get the comfort based on the breeze. Otherwise, if it is stuffy, especially when it's extremely humid, if there is no breeze or the wind, you get suffocated, right? I think it's not the temperature anymore. Because naturally in Kerala, you find that the temperatures are lower in monsoons, throughout the country, especially. But the problem in the monsoons and the humidity is actually far more worse, personally for me, than actually summers for my body type, because it's the humidity and the like your body cannot sweat and you start feeling, so you like, I mean, you need some kind of mechanical force or something, the breeze to constantly be there, otherwise you feel uncomfortable. And this is, it can be extrapolated to different parts of the world, and how traditionally architecture has always responded to right, to the climatic conditions. So when we are looking at, especially in the practice that we do, like passive and this one's low energy cooling solutions, this was the first the prototype that, or the project that I did, and that put us in a different trajectory altogether, apart from the practice of architecture that we practice. So there was a time when I was absolutely fascinated by this computational design and parametric forms, which I am. And but the only change is that we try to do the same thing using traditional natural materials. So the idea has been that if this is a beautiful example, which is very low key, traditional, and the temperature in the earthen pot remains naturally cool by simple latent heat transfer. So the water is very comfortable to drink, and this one. So we thought when we were working on this, Jenny started with putting this in front of a DG set. We are dripping the water on this. So instead of trying to cool the water, we wanted to utilize the capillary action of the terracotta, because it naturally retains moisture inside that. And instead of trying to cool the water, we thought, what if we cool the air? And it worked, and we started looking at how this can be then taken to other forms. Rather than ending it right here, we thought, what if we can take it? And we started working with potters and local craftsmen to do it. And today, I also have Yogesh Bhai in the audience, one of our partners helping us with these systems like developing, and he is from Gujarat, so pretty happy to have him here. So, how some of the systems that are there, how we can take some of these and try to, rather than reinvent them, but rather engineer it. I think that has been our focus, rather than trying to reinvent the wheel. Most of the traditional systems that we talk about have worked very well in the past. So maybe it's not ideal, and maybe it is not holistic to say that I'm going to use the systems exactly the same way they're designed before and use them in modern way. I don't think that's going to work, The only way that we can make the traditional systems work is if we engineer it and make it adapt to the modern buildings. Because today's the typology of buildings in today's date is extremely different from the way traditionally buildings used to be designed. And so when you're talking about, again, going to the roots of climate responsive, like climate has found beautiful ways in all species, like, which are natural, to respond to the changes in season as well. So when we say climate, it is not a static entity. There are parameters that keep changing and reflecting as you keep moving to sweat and keep ourselves naturally cool based on, like, we regulate the temperature, right? But what happens today's date is that, I'm sure most of you agree, is that we do not perspire as much as our ancestors or like our parents or our grandparents used to do, which directly contributes to the even the health. Sweating is good and exercising is really good, right? And we end up actually, to force it, we end up going to the gym and all, because day to day in our lifestyle, we do not have access to the, we are not really comfortable with the either slight heat or, excessive heat is always very difficult. But our bodies are tailored in such a manner now that we cannot actually take these changes anymore. And we are depending extremely, relying on this mechanical systems in today's date. So coming back to architecture, so this is how, like, what we are trying to do in here is that, okay, now this has all been whatever, so much of, like I said, most of it you already guys know this, like there's nothing new. And so the idea has been, how can we bring that into architecture, into the buildings that we are designing, and see what we can change in that case. So the first project I'll be talking about is in Hyderabad. Hyderabad is predominantly hilly terrain, and some of you guys who are familiar with the terrain would, relate to this. So the site that we got is large boulders, and what you see is the client actually over there. They have cut some of them, trying to build a house on top of this. So the first thing, so what you see on the lines in here, they've already markings that are done, and they were planning to blast the rocks and actually create like a typical foundation on top, and then make a house on top of this. But what we realize is, so when we first got into the project, they already had a plan which they were going to build. So I requested the client to mark this as it is, where it is coming, and understand how that is going to sit here. So later, so this is the location in Hyderabad between the airport and Gachibowli. This is this beautiful stretch, the highway. And this is Himat Sagar Lake on the western side. And in the north, we have this view of the Gachibowli. In the south, there is this, the hotel that was coming up. So this is from the south, you're looking towards the front. So the way, these are massive boulders like rocks, and the scale of it, look at the size of the JCB for you to understand the size of these boulders. This wall and these things were existing already. This part of it, this part of the site was already blasted so that they can make the foundation before we got into the project. So what we requested the clients is, before doing anything, to completely unearth, even before drawing a line, scoop out the land and then see what we can do. And we try to convince him, saying that, okay, there was one thing that the client said, that, you can't do anything on the rock, because that's the reason why in Hyderabad, most of the people don't build exactly, they flatten it. And then because the Vastu doesn't allow it. And that doesn't honestly make much sense to me. I did not argue with him, but the only thing what I tried doing is that show him some of the beautiful examples of rock cut architecture. Our temples earlier used to be carved out of rocks. And you guys know these buildings like marvels, where the whole earth, the mountain was sculpted out to make these spaces. So saying that rock cut is not Vastu compliant is, in a way, probably blown out of proportion, right? I think it's just convenience. It is simple convenience that people don't want to take the challenges of working with the rock anymore, because the modern way of making buildings with brick and mortar is much more faster and easier, isn't it? So we always camouflage convenience with some kind of lame techniques or belief system to get out of the situation. So I think after showing these examples, saying that, okay, how traditionally the client was really convinced, even though he was extremely possessive about saying that he wanted the building to be Vastu compliant. So what you saw earlier, and what we did, we scooped out the land, cleared all these rocks completely, and we convinced the client, stating that let's leave the rocks untouched. No matter whatever we do, we're going to build on top of that rather than touching anything. So let it be the way it is. So, and we said, okay, we're gonna take this and then start with it. You can see the highway on the side. The beauty of the site is that you don't see the highway from the site. That's how these things, you can see that right from here. So this is after we scooped out. And then what we guys did, like I said, we love actually working with combining technology and traditional systems. So what we said to the client is, rather than using the typical contouring method of understanding how the belief this is coming, 3D scan the whole thing, converted what is physical into a digital space using photogrammetry, and got this thing completely analyzed, so that we're able to pinpoint when we're plotting the building on this, we know exactly every point in space where we can mark it. And that is really important for spaces like this, is because this is how it is after we scooped out the whole rock system, is because when we're making the building, what is the first thing that we do? Guys? Students, right? What do we do? Create a foundation. So what is the standard size of a foundation? I mean, there is no formula, by the way, it depends on the land, but basic, let's say 4 feet by 4 feet, 5 feet by 5 feet, whatever. And you have to go, the minimum the structure consultant says is you have to go 5 feet deep. Or till you hit a rock. That's what structures say. Either you have to go 5 feet deep or till you hit the rock. And the standard. So when you're making something like this on a plot like what I have shown you, you have to make this huge. That's the reason they were blasting the rock. So in here, the idea has stemmed from, this is what we finally came up with. But if you look at the columns on how we pointed this, were done with just a pivot of 450 millimeter diameter and anchoring it to the rock and taking it deeper rather than blasting any of the rocks. And very precisely so that we don't have to do this. And the entire project is the form of the building responds to the way, like, we're talking about fluid architecture, the modern trend of how we design like spaces. But at the same time, the idea has been that what if you blend it in traditional materials that we have been using for hundreds of years. So everything that you see in here, we said, okay, what if we take timber, wood, north lighting on the top with this terracotta on the roof tiles, what we're talking about. And you can see that in here. So we have made this spaces only where there is soil, and the rest of it on the rocks, we have given these columns that are sitting on the build in there. And in cross section, like I said, this side is facing south and that is towards the north. So the north is full of glazing, and it has also like a beautiful skyline of Gachibowli in the night. On the southern side, it's extreme heat, and also there's a hotel that's coming up. So for the sake of privacy, we created a skin that is, that cuts off the heat, still has the view and the ventilation, but doesn't, and also cooling happening from the southern side. And taken the north light on the top so that we can bring in the north light into the space. And the whole form is sloping, so keeping in mind, different seasons together. And on the ground floor, rather than proposing a living room like a standard one, we convince the client, what if we have a natural living room on the ground floor? So it is pivoted, stilted, so you have this, and in between this rocks and crevices created a proposed pool that can go to the end of it and create a infinity pool kind of a thing facing the lake in the corner. So yeah, this is the southern side, what I was talking about, facing the and this is actually where we started with the referencing with the client, how traditionally the buildings used to be, but then how we can like relook at them in a modern way is what has been the idea behind this. This is some of the materiality that we have used, the same materials that we have always used before. And moving on, while this has been the design approach behind the project, so one of the key components that we have developed over many years is what we call as this aero leaf, which is the shading device on the southern side. I'll be talking a lot about how this thing as we move a little later, but this offers pretty tremendous flexibility in terms of the design. And this is something that is developed and engineered by us. And the idea of this has been that evapotranspiration happens in the trees. So can anyone guess, on a hot summer day, when the temperatures are more than 40 degrees, when you walk under a tree, we all know that it's naturally cool, right? You just move under a tree and there is an instant drop in temperature. Why is it so? I mean, the image is right here.
The water takes away the heat.
The water takes away the heat. And this evapotranspiration is happening from the roots on the ground and also from the leaves on the top. And that's the reason, even if it's a shade and you walk under a metal shed, do you get the same kind of an effect? So can we guess in terms of temperatures, how much temperature drop you can average expect under a tree under a metal shed? It's open on all the sides, the metal shed, whatever. Just guess.
2-3 degrees.
Sorry?
2-3 degrees
Under a tree?
under a tree.
Okay. So if it is 42, so when we walk under a tree, the temperature we get is around 38, 39 degrees. Yes? Okay. What about if we walk under a metal roof? What happens? Like any other shading shed. Okay, its temperature is lesser, more, or same? Is it more? But I'm saying it's open on all the sides. It's not a glass house. It's not a greenhouse. Still more? Okay. So when we talk about nature-based systems, right? It's really very interesting how it's very interesting how different elements play a component in creating this thermal comfort or the shading. So one of the most important factors, even without evapotranspiration of water, is the shade itself. It has some effect, but not as much as under a tree. Probably the temperature, depending on the humidity and other values that are there, could be 1 or 2 degrees or 3 degrees when it is open on all the sides. If it is enclosed, then it's a heat trap. It gathers heat, you feel even warmer, like a greenhouse or something where you have this glass house. The moment you put water in it, evapotranspiration, the temperatures go like 7 to 8 degrees. Easily you can get the change in the temperature the moment you walk under a tree. Okay. And another most fascinating task or the thing about nature or the system that we're talking about is the color. And the moment I would love to talk more about the color maybe in some other day. And even the way that we play with the colors has extremely different impact in the, and it's magical. For me, color is one of the most magical things that nature has given us. The amount of radiation that it absorbs and the pigment and it reflects itself has extreme impact on the way talking about the waves that it absorbs, right? We know I'm wearing black winters, it's pretty comfortable. And if it is summers, naturally we will shift to linen. What is recommended? I mean, of course, we live in a society where we extreme hot, we put ACs even in winters and then sleep under blankets. So that's how, but that's not the case. In nature, when we're talking about the color itself, what it absorbs has extreme impact on it. I think when you look at it from an architecture perspective, it is magical. So like I said, maybe for some other day, I would love to actually discuss color, but today, evapotranspiration, what I was talking about under a tree. So we thought, what if we take that element of the leaf and how it is taking the water and creating that impact, and if you can mimic this on a building elevation or the envelope, so that it is giving you the same kind of a thing, and as the air brushes through this, it has this, the surface temperature of the material is lesser than what it is. You're able to provide the basics of shading, orientation to the sun. You can cut off the heat that is coming in, and you can adjust it, the spacing between these, the way that you want to optimize the daylighting. So a traditional system, so you have the flexibility to optimize the amount of light that is desired in a space. You can adjust the angle so that you can get the you can cut the heat that is directly coming, or you want the heat to come in. You have that flexibility to do both. The orientation, what I mean by that, and the evaporation is happening from the skin of it. And we also tried doing this on, this was a project in Bilaspur on a commercial building, and you still, without cutting the view, this is how the view is from inside the building. Okay, so while you're cutting the heat, you're not actually cutting the the view to the outside, but from outside, this is how it looks. You also have the privacy if you desire, and so yeah, this is what we can do. And like I said, modern way, what we really wanted to do in here is that while all of this, like I said, are trying to take some of the traditional principles, but at the same time, wanted this also to be parametric. Like if you look at the wave that is created, we wanted this to be computationally designed, get enough sun throughout the day, as the sun is, because sun is not a static entity, right? It keeps moving, and this is a southern facade. So what we wanted to do in here is, as the sun is moving, at every angle, we bring in some sun into the space, but not block it entirely. So the whole facade is designed in a manner that every moment we have some amount of light and shadow that's coming in, but you're blocking bulk of it. And this was done with the help of optimization and all that. So this is another project I'll talk about, the design optimization a little bit more. This is in Nagpur, and it's an ongoing project right now. So if you look at this, so west side is taking the bottom floors, and they did not want any anything that blocks their the shop site. And it's a brief by them because we don't want to. We want the shop front because that's marketing for them, whatever is there inside. So okay, we don't want anything. And there are two other people who are already getting the restaurants in here. They also said, okay, we are going to have air conditioning. We don't care anything about the environment, so let it be. So the client said, what if you guys can do the entire office spaces and other blocks that they have some residences to be climate responsive, cut the sun, and how do we go about this? So what we started, and it's in Nagpur. I'll not talk to you guys about. I mean, you already know that it's one of the hottest cities in the country, and this is how the floors are: retail, offices, restaurant and owners floor, and all that. So what we guys did in this case is took this model and started looking at first basic principles of daylighting optimization, so that how we can optimize the whole envelope that we guys are doing so that we get optimal daylighting on the floor, and also understand what is the heat intake that we are getting in. So that informs us about how we can design, to what extent we need the envelope and what extent we don't need the envelope, and so on. And what we guys have done is that shown some of these options before coming at the final design resolution, like how we can design this, weave it, have some punctures to bring in some light all across the floor, and so on and so on. And also some options like this, which are pretty, parametric and fluid, and still following the same principles. So the method that I was talking about with the aero leaf earlier, so we can adjust the angle according to the sun. We can adjust the spacing based on, like I said, the daylighting that is required, how much daylighting we need within a space or we don't need it. And the last part of it, like I said, you combine all of this, the spacing, the angle, the density. And so we have run simulations to understand on this, like quite a bit of simulations to get the right amount of daylighting and also the optimization. So in terms of, you all know the basic concept of wall-window ratio, right? So we have taken to the same in here and said that, okay, what if we take this in here and start optimizing it based on that, so we get the right amount of the envelope for this. So based on which later converted that into this, the density that we have taken. So at each level, there is a play, but they all follow the same values in terms of the parameters, and getting the, like I said, the right amount of sun inside the space. And finally, we have this. So yeah. So this is about, I would say, the idea behind this, where it started with a simple idea of like the prototype we have seen in the office and the studio. Now trying to do this at a larger scale too. This project is for a factory again. This is what these guys do in a factory. So this is a forging area, and there's extreme heat stress that comes from the machines. So especially for workers who are working in an environment like this, so when they step out in summers, I think you can imagine the amount of the heat stress the body goes through, right? And then obviously for them, even dur tak, air conditioners is not a choice, okay? For two reasons. The first thing, the factory is not going to provide them unaffordable, right? What's the second thing? Any guesses? Why air conditioning is not an option for them? The first thing, unaffordability. The client is not going to provide. But even if he can, so why is air conditioning not an option for them?
Sudden change in temperature.
Yes, thermal shock. So if there's an extreme change in the temperature, if you're working in an area more than 50 degrees in here, the furnace, I think even more in this environment, and if they're going to enter into a space which is almost, you're looking at 24, 18 degrees, the kind of thermal shock the body gets is going to be extremely making them sick. And that cannot even happen at a day-to-day. So when we are looking at the space or the design for this, so what we recommended the clients is, we have something and which is elevated, fully passive on all the sides, like this. On the bottom is a canteen which they can come and go, shaded, have summer screens and monsoon screens for the rain, but it's like a quick come and go. And whereas on the top, so in this case, what we recommended the clients is we're going to do something. The roof, the form is like completely open on all the sides. The bulge, so this, I'm going to show a section of this, is fully ventilated from all the sides. These are all the Mangalore roof tiles. So we said, okay, in here, we're not going to be pouring so much water like all the sprinkling system. We have sprinklers and all to wet the tiles because terracotta retains moisture. But what we suggested is that what if we take the same form of it, but the roof tiles, because roof tiles also is terracotta, it absorbs 5%. In the cases that we developed our own product, there we control the porosity of the terracotta. We have that option, but something that's already available. So we said, okay, what if we use this? Then we can do the shading, and in between the skin and the bulge, this is the layout of this in the middle, where people can actually come fully here. Like I said, on one side is the kitchen, and other side is fully passively ventilated. This is how it is. This is a cross section. So we get this idea of having this, like the plants, there's a window in between, bring the light in, and we are using the sprinklers to just wet the tiles from inside, cut off the heat that's coming in, and use this cross section to, there's a skylight on the top. And all the hot air that is collecting, we use mechanical ventilation to pull the air, force the stack effect, and take the air out. And that was the idea behind this work. So on the top, we look at the section of this. During the day, this is how it is. It is naturally lit, and you don't need any artificial lights during the day at all. And we have this, the section of this in the middle is the place where people can come in. And on the top, the seating is provided all across, and with this just like a garden on the side. And so this is something that doesn't need, a lot of maintenance, fully open. Whenever there are monsoons, you can just cut off, you can roll the blinds if it is maybe in winters. And in winters, you also have the top thing to bring in the heat inside the space. Okay. So another project, and in here, we got into the project after the building was already made. It's already there. So we were invited to be part of the project to design the envelope, especially from the perspective of how we can reduce the heat gain. So the building is already partially air conditioned. It's offices on the top, some spaces on the bottom, which are naturally, it's canteen and open. So it's a mix of air conditioned and non-air conditioned spaces. So when we got into this, so we wanted to again play with this, but in here we said, okay, because as architects, we love to, even if it's our own product, like the role, if we don't want to repeat it on all the projects, we find it boring, right? Unlike the product industry, which is used to copy pasting everywhere. So we have this inherent way of like not wanting to do something that we have done for others. So we get into trouble because of that. So in here we said, okay, to the client, what if this skin, because these guys, ITW is one of the leaders in the automobile industry. You don't hear the name, but they supply their patents and stuff to all the automobile manufacturers for certain components that they're very famous for. And so in the facade, they also wanted to show this is what they are pretty popular, EVs, automobile and industrial tools that they develop. And so we said, okay, can we do a kinetic screen for them? Because they are champions in engineering. So this is a kinetic facade that we designed for them. So again, we went back to I'll skip through this, understood the wind and the radiation and whatever for the heat gain and how much light we're getting. You know this by now. We were able to do this with the help of whatever optimization softwares and so on. But the idea behind this is the skin, which is facing the south and the western side. We said, okay, like again, in this case, sunflower is a beautiful example, right? How it orients itself according to the sun, opens and closes. There is a bit of this. So what if in this our skin that we're talking about, we have this skin that is developed like this, a mechanism 100% mechanical. You can control it just by pushing it. We have developed these gears. So you just push one, it opens up, letting in the amount of whatever you can control the apertures in this just by adjusting the amount of opening that you want to do. And theoretically, this can extrapolate even like whatever size that you want to, but there will be frictional forces and you cannot make probably a 100-meter long facade just with this. So what we did, we broke it down and made the smaller components. So each one of it from their window, they can just operate based on how much light they want to let in summers or not, and so on. And the rest of the areas we have given this between the building and this second skin for the garden, the greens to grow, and also some bit of natural light directly coming into it. So that we was able to create this. So the whole facade is designed like a vertical garden with shading device integrated. And so yeah. And this is the also like an interesting part in the project. So whenever they have a new vehicle that they have to demonstrate to the clients, their clients are like Tatas and the Mahindras. Whenever they have the vehicle, they set up their components and they have to display it. Now they're showing a car. Now we have a show a car. You can either do it in a completely sealed environment, air conditioned, or we can, because car is always it's an outdoor product, right? So we said, okay, what if we have a bio atrium, an atrium that is typically, normally atriums are like quite energy intensive. So design this atrium which is fully like a garden, and then you can display, you can bring your car in here, display the whole product. On the top, there's a conference and all, and have this fully open on all the sides. So for the same client again, this is the Lighthouse project for the same ITW guys. So in here, we wanted to reinterpret how the wind catchers used to work in the past and see how we can bring that. So they also had a factory, this one what you see on the side, pretty huge, 139 meters by 139 meters, and 12 meters is the height of it. It's massive. So doing anything on the skin is impractical, and it's extremely cost wise, right? So what in this case we have done is, under the factory, there are earth-air tunnels that are already laid out, equally distributed, and there is this earth-air tunnel that is coming on the side, captures the wind, cools it, and then releases into it, inspired by how traditionally, like I said, showing these examples of how it used to be done. But then like I said, the challenge in today's date is the sizing and understanding how much of it is sufficient for a space. And that's where offsetting these two gives us the mechanical, the loading basically, and trying to design the space for that. So we have gone through the set of, again, the simulations and calculations for this to size this, the diameter, the size of it, how much wind are we flowing into it, and done a lot of CFD analysis for this to get and size the earth air tunnel, so we are able to draw the air and pump it inside the system. So, and that's how we started. Then we started also looking at the shape of this. We can make it even a bit more exciting in a way. And so redefining how the earth air tunnels are there and then pump it in. So a lot of analysis for this. And finally, this is the earlier option, how this works. So this pulls the air and pumps it into the earth air tunnel and then released into the spaces. So there's a lot more in terms of ventilation systems that we have designed for this. So this was a prototype we have done before we went into this, because it's very difficult to convince a client to do something like this without having a prior experience or something like this. So what we have, this is a project that we have done in Mumbai for Conscious Collective this year and also last year. So this was a smaller prototype of the same idea, where we prototyped and showcased how the system is going to work. This is the last project. So this is a sports complex. Why do we play sports? We get bored. Guys, sports क्यों खेलते हैं? Fitness, correct? To be fit. Okay. How many of you have go to sports complex or something like that, or experience of going and utilizing the spaces? Okay. So how many of them are air conditioned? Leaving the gym area? Okay, I mean, you need some kind of comfort, your body is sweating and all of that. But isn't it an irony? You need some comfort, it's agreed, but you're going there to sweat. Isn't it? Correct? And another key factor is, of course, you need thermal comfort. You cannot have excess heat, so you need some kind of moderation in the space, understood and acceptable. But there's another challenge with that, especially for those of you who play badminton. Is comfort only the challenge? Wind is a challenge, right? So what happens is, most of the sports complexes, you cannot have direct wind coming in. For the shuttle, so you have to enclose the space. Even with air conditioning, it's very difficult. You have to be very careful about the flow of air and how the air is moving inside the space. Correct? Shuttle. So what you end up doing is, you don't have a choice but to create a box and then cool it, right? And for whatever the cost and other factors, you can't even, most of the sports complexes even have a tin roof on the top, not with proper insulation. It's more expensive to do that. So this is a challenge. So when we're doing this for a school, is my time up? There's a very polite way to say so. Ab band kar do. Anyway, this is the last project, guys. I will not bore you guys any further. So, am I audible? Yeah. So one of the key factors in this is that badminton, the shuttle racket, that's an important factor. You need the space to be cooling or creating thermal comfort, but you cannot have direct wind flow. So even if we say that we're going to have a beautiful space with a lot of wind and everything coming in and all of it, it's not going to work. So you need a closed box, right? So what we suggested in this case is, what if the whole building, you have windows which are like this, and a lot of light that is coming in, simple Venturi effect, take the hot air out and all. But These areas where we have the windows, they can open it whenever they want, but primarily the walls are designed in a manner that the whole space is breathing. You're not getting the direct wind. The whole wall is, I mean, I'm sure you guys know the Gabion wall system, but in this case, we have been using it Gabion with a lot of internal ducting as well, wherein the wall breathes, provides cooling, absorbs, retains moisture. Even a broken brick has the same properties of terracotta. It absorbs and retains moisture, right, and cooling. And we're growing creepers on top of that. And also, like the last project, what we guys have done is that taken this, some bit of earth tunnels underneath and release them in the middle of the project, not from the top, so that we are diffusing the air at the lower level. So the cool air is always at the base. This section explains this in here, releasing the air, not releasing the wind from the top. And they can play multiple sports, not just badminton, basketball, like whatever. The whole space is like a multi-purpose hall, but they have a lot of the courts in the middle. And I'm bringing in enough supplementing daylighting throughout the day for this. So yeah, I think that's about this project, and this is how it looks from inside. So I think I can go on and on, but any questions? Maybe we can try wrapping up the some installations and all I've been working on for the how to make public spaces comfortable using installations and art installations and so on. Another project in Lucknow trying to use the traditional architecture of Lucknow and then make the building using the same ideas of this, but in a contemporary manner. So yeah, any questions? Yeah.
What are the for domain such and all of that?
So we use, see, the first thing is the design. So when it comes to the design part of it, we are a little old school. We work with a lot of sketches and ideas and whatever, stuff like that. And that's very important. What I'm saying is that most of the time people consider that it's only the software that's going to make an impact, but that's not true. So the first step is the old school way of designing. And then we use Rhino and Grasshopper mostly. And in some projects, if it permits, we also use the Python encoding and to optimize. For example, in the Nagpur project, we have optimized the facade, right? So we have done it with the help of coding in Python. And then for the analysis, especially the daylighting and all of it, all the plugins like the Ladybug, Honeybee, and all of these plugins that are there to help it. And we also work a lot with consultants who are also from this domain, because most of these things like also need technical expertise. So after designing to a certain level, we bring in experts into to the project who can help us with the optimization of how we can run the projects. Any other questions? Yeah.
I'm just concerned about the maintenance of these kind of facades, but with time it ages, and the natural property definitely comes out with the we are using terracotta in most of the facades and as a building material. But as an architect, we are conscious about the nature and environment, but not the general people. And they try to forget, like once these things are get installed, and after a year or so, like see, I visit first time in this building, I'm seeing these cracks.
That's a concrete, yeah,
that's
definitely.
concrete. So I'm just concerned about the maintenance, the life of the building, and again, there are many factors which are considered. So what is the solution for that? Like, and how we can be a part of that thing? Generally, we take it as like AMC is the thing, annual maintenance or something. So do we have something sort of that as well, like for the life, so that we can maintain it, or like maybe
Absolutely.
somebody who is there, maybe the owner or something. We have some proposals for that as well.
Surprisingly, this is whenever we have a space, and we also work a lot with exposed brickwork in our projects. So brick is a breathing material, as in even if otherwise, if it is exposed on both the sides, the building, because the water comes in, it goes, it dries off, no problem. The only problem is when you start plastering it on one side, you're not leaving the natural mechanism of water to evaporate and leave. So most of the old buildings, I'm sure in here, Ahmedabad, there are crazy examples of how exposed brickwork is used. It's one of the best cities to do that. So if you're not understanding the material properties of this and not stopping water, and guys, you know mud fusca, right? Right? Traditionally, isn't it counterproductive that you're using sand and mud on the top for waterproofing and this thing? So the only problem, that challenge that comes in, this is actually pretty interesting example for me personally, is that you are letting the water come in mud fusca or the waterproofing that you're doing on the top. But the beauty of that is that you're letting it evaporate. And after some time, the water, that's how you're maintaining that waterproofing both, and also the insulation properties, how traditionally it's done. The challenge comes in, imagine you have a mud fusca on the top and you're putting another waterproofing layer and another tile on top of it. So what happens? Has anyone faced this problem? Yeah. So please. It doesn't have the route to escape, yes. It has to come down, right? I have this crazy example. We are working on an interiors project, and we were asked to design a staircase that takes from this third floor to the terrace. So we ended up cutting that. The slab is almost like it's supposed to be 6 inches. When we cut it, it's almost 15 inches. Over 3 times, they had waterproofing issues. Every time, instead of correcting what is below, they started adding one more layer and one more layer on the top. So what happened when we cut it? It's a waterfall. It's a sponge. It gathered all the water, and it is crazy the amount of water that came out of this. Continuously for 3 days, we were having, like, in the building, there's water that is dripping. Not dripping, it's like you can see, we had to keep buckets to collect the water. So talking about terracotta, the way that we do, we absorb the water, but it is disconnected from the building. We let it evaporate. And surprisingly, we have been trying to gather moss on top of it. And moss is really amazing for air quality. We are struggling to grow moss on it. And it only grows when it is, because it evaporates. There's air and you stop the moisture, you regulate the amount of water flow that you have in. We are not constantly pouring water like in a desert cooler. We pour the water, we drip, we stop. We drip, we stop, we're automating the system. And then what happens is, after some time, the terracotta, it cleans itself, it auto-cleansing. And even if there is mud, if you don't pour in water, terracotta is such that all the old buildings, you don't see the water on it, right? Or the mud on it, the dust. That's how beautiful it is. And the water absorbs and evaporates. So there is no problem as such. It's only continuous atmosphere when you have moss grows, and we really love moss. Actually, moss is really nice, and if it grows, it's fantastic. But let's say some people don't like it, okay? And there are always people who don't want moss. It's not like everybody's taste is the same, right? They think it is algae or fungus. Moss is not algae, moss is not fungus. It's a different species altogether. It's good. So what happens is, even then, in today's date, we have beautiful laser cleaning techniques. Terracotta is baked at 1100 degrees. The pores are filled, moss and all of it. We have a laser machine, you just clean it. It's auto cleaned, you don't even have to take things out. We used to take out and then whatever, clean and replace new tiles. It's not required. You just have a backpack with a laser machine and you can clean it, wiped clean, like it's brand new. So it's not a problem. So that actually, if you can engineer it, like I said, it's not an issue. But yes, water, but I understand what you're saying, is the most difficult element in the house. Like all the experienced architects will vouch for this. Water will find a way in. It's much smarter than we are. So it will find a way to come in, okay? That's true. But there are a lot of techniques where we can control it.
Thank you so much.
So the aeroleak that we have designed is of terracotta, right? And the way it rotates, is it manual or automatic?
No, it can be rotated manually and also automated. It's just expensive. But most of the places we optimize it, create this according to the design patterns and leave it. But it is possible, it's just a matter of cost. You can automate it and rotate and make it control it with the same mechanism. But yeah, we leave it static, different patterns. That's it. Thank you guys. Thank you so much for having me.